Hey everyone, welcome back. So in this tutorial, I'll walk you step by step through setting up a fully automated deployment pipeline for a full stack web application. So we'll use React for the front end, Django for the backend API, and MySQL as the database. So let me walk you through the deployment stack. So in this project, we are going to use a full set of technologies to build, containerize, and deploy our application. So on the front end, I already have a React application, which I'll serve using Nginx inside a Docker container. And on the backend, we'll be using a Django REST framework to handle API request. This will also run in a Docker container with its own isolated Python environment. And then for the database, we'll set up MySQL managed as part of our Docker Compose network so it integrates smoothly with the backend. Then moving over to AWS services, we'll provision EC2 instance to host our containers, and then we'll use Elastic Container Registry to store and version our Docker images. And Route 53 will manage our domain name and DNS routing. Along with that, the application load balancer with AWS Certificate Manager will handle HTTPS traffic and SSL termination, so our application is served securely over the internet. And then finally, on the DevOps side, we'll rely heavily on Docker and Docker Compose for container orchestration and GitHub Actions for automating the whole CI/CD workflow whenever we push code changes. And finally, we'll configure AWS security groups to act as firewalls and control network access to our services. So I've majorly divided the whole project into two parts. So I already have an existing React and Django app for deployment. I'm going to containerize the app using Docker and Docker Compose. But then for the initial deployment, we are going to use the local terminal. And after the successful initial deployment using local build and SSH to EC2, we will finally go ahead and automate the deployment using CI/CD workflow using GitHub Actions. So this is the generic workflow. So you develop your code. This is gonna go to GitHub, and on code push, GitHub Actions will trigger a workflow, which is this CI/CD pipeline. So this workflow is going to do two main tasks. It is going to build and push Docker images, and then it is going to trigger the deployment. So in this step, the React app, Django API, and MySQL configuration are packaged into Docker images. These images are then pushed to AWS ECR, right? Elastic Container Registry, which is a private Docker image repository. And after pushing images, GitHub Actions SSH into your AWS EC2 server to pull the latest image from ECR, and then it will also restart Docker Compose so the new containers can go live. So these two things are happening via CI/CD pipeline. And then we have AWS Cloud Deployment Infrastructure. So here what generally happens, right? A user will open your website, right? Whatever your domain is in their browser, and then AWS route, which is in this case, we are going to be using Amazon Route 53. That is gonna map your domain name to AWS resources. And then AWS Application Load Balancer handles HTTPS encryption. It is going to forward your HTTP traffic to your backend servers, which is in our case going to be EC2 instance. And your AWS Certificate Manager, it is going to provide and manage your SSL certificate, which is going to enable HTTPS securely. And then your AWS EC2 is the virtual server where Docker runs, and it is going to act as the main compute resource hosting your containers. And then your Docker Compose defines and orchestrates the containers. So the front end container runs your React app, the backend container runs your Django, and then the database container is for MySQL. So here, as I mentioned, for the traffic flow, the application load balancer forwards HTTP request to the EC2 instance, and then inside EC2, front end serves the React app, and then API requests from the front end are routed to the backend container, and then the backend container makes database query to MySQL container. So let's go ahead and get started. So we'll first write Docker files for the front end and backend, and then we will do the initial deployment using local machine. So we'll build and push Docker images to ECR. We are going to SSH into EC2, then we'll do a pull and deploy with Docker Compose on EC2 instance, and then we are going to automate the deployment. So I'll move to my VS Code now. So let's start by Dockerizing the front end. So I'm in my front end app, and here in front end, you need to create two files. One would be Docker file, and the other one is nginx.configuration file. All right, so let's just go ahead and create the Docker file. You need to create this file without any extension. So just type in Docker file and enter, and this has to be at the root level. Let's also create the nginx config file. So nginx.conf. So in the Docker file, we are going to keep the instructions for building the image, and in the nginx file, we will keep in the configuration for the web server that will serve the React app. So let's start with the Docker file first. Let me put a comment here. So in stage 1, we are first going to build the React app. So this is going to be a multi-stage build, and the first stage is purely focused on building the React applications, static files, and we use a Node.js image because React development requires Node.js and NPM, right? So here we will use something like this. So from Node, and we can use Alpine. After this, we need to set the working directory inside the container so that all the subsequent commands in this stage will be executed relative to this directory. So we have to set the working directory inside the container, and for this we have command as work directory. After this, we need to copy package.json and package log.json into the containers, and we copy these first separately from the rest of the code to leverage Docker's caching. All right, so that means if only your source code changes but dependencies don't, then Docker can use the cached result of the npm install step, speeding up the builds. So copy, and then we have to copy both the package JSON files. So package star.json. Now let's install project dependencies. So the command that we are going to right now is going to read package.json and install all the required Node.js packages. So run npm install. Now we need to copy rest of the application code into the container. Basically, like whatever you have under source public folders, right? All of that we need to copy. So here we'll write copy paste dot space. Now we need to build the React application for production. So the npm run build command is going to run the build script defined in the package.json. So for that, so this command runs the build script defined in the package.json, as I said, and it compiles your React components, like, and optimizes them and outputs static HTML, CSS, and JSX file, or TSX file in our case, into a build directory by default within the containers app directory. So whatever it is going to build, it is going to output static files, and it's gonna keep it under the working directory app that we had created under a build directory. Now we need to serve the React application with Nginx. So let's just write. So we need to switch the server. So from Nginx. So this is the second stage of our multi-stage build. It creates production ready image, and we use Nginx because it's very efficient web server for kind of serving static files like our build React app. Now the configuration file that we would be creating, everything that we have inside this, we need to copy that. So let's just write a command for that as well. So this file tells Nginx how to correctly serve our single page React application, especially for client side routing, and it's copied to Nginx default configuration directory. That's all we are doing here. Now we also need to copy the build React static files from the build stage, and we need to copy it into Nginx default public web serving directory, and we need to copy from the build stage that we have above build, and then we need to give the location, and then we'll expose port 80, and then we need to give the command to run Nginx when the container starts. Let's just go ahead and do that. So here Nginx -g daemon off, it runs the Nginx in the foreground, which is necessary for kind of for Docker containers, so that the container doesn't exit immediately after starting. So let's save this file. So these are the only steps that we have here. So we have stage 1 and stage 2. So here let me just type in as stage 1. Now we can go ahead and run the docker build command, but before that, let's just also set up the config file. So this block defines a server configuration for Nginx. Here under the server block, we have port 80. That means listen on port 80 for any incoming HTTP request. So this is a standard port for anyway, web traffics. And then we have to set a root directory for serving static files, and this path actually corresponds to where we copied the build React app in the Docker file. All right, and then this one is basically defining the default files Nginx should actually look when a directory is requested. If a request comes to as in with slash, then Nginx will first look for index.html, then index.htm, and then here we have to configure Nginx to handle client-side routing to React applications. So this is also crucial for any single page applications, right? Like React. So location slash means this block applies to all requests. So this is to configure Nginx to handle client-side routing for React applications, and this is also crucial for any single page applications like React. So location slash means this block applies to all requests, and this is optional. This is just to add caching headers for static assets to improve performance. So you can either have it or you can ignore it as well. This is just telling the browser to cache these file types or for a year or so, reducing load times on subsequent visits. And then also for faster delivery, you can do the compression, but as I said, this is also optional, just like we had the location image caching optional as well. Now we can go ahead and run the docker build command. So I'll go to the terminal, here docker build, and then we have to provide a tag, and we'll provide it as my frontend app, and then I'll just name it as latest. You can give any version that you want, and then let's run this. There shouldn't be space after these, so we'll remove that. Let's just save it again and then rerun this. So now we can go to the Docker and see the latest build. So this is the build that we just ran. So the build is successful now, and if you go to images, you can see the latest image as well. Now let's go ahead and Dockerize the backend. So in your backend folder, if you don't have requirements.txt file, you can create one at the root level and then create one Docker file as well. So in your requirements.txt, you can list all the Python packages which are required for your Django application. Here I'll mention some version, like whatever I want, and then Django REST framework. And then we also need course headers, so that for handling course origin resources requests from the front end. And then we also need Gunicon, which is a Python HTTP server, and it is used to serve Django applications in production environments inside a Docker container. And then we also need MySQL client, which would be a Python adapter for MySQL. So MySQL client. So now I have the requirements file ready. Now let's go ahead and get started with the Docker file. So we'll start with stage 1, which is building the Python dependencies. So here we are using Python 3.11 Slim Buster image, which is lightweight Debian based image with Python 3.11 pre-installed. So this version is compatible with Django 5 and above. Now we need to set environment variables for Python. So Python unbuffered ensures that Python output like print statements or log and is immediately flushed to the container's logs rather than being buffered. And then we'll have another one here, it should be env. Then we'll have another one which is Python don't write bytecode. So Python don't write bytecode, it prevents Python from writing .pyc files, and these are basically compiled bytecode files that can sometimes cause issues in containers, and they kind of slightly increase image size. Now we have to set the working directory inside the container for this stage. Now we need to install system dependencies. So first we need to update the list of available packages in the Debian repository. So we'll start with this. And then we'll install the packages. If I break this down, right, so app get install is installing the package, and the no install recommends prevents installing recommended but not the strictly required, keeping the image smaller, right? And then we have to also include build essential, which will provide essential compilation tools like GCC and G++, which is kind of required to compile Python packages that have C extensions like MySQL client. So build essential, and then we'll include package config. So package config is it's a utility that helps compilation by providing information about all the installed libraries. So MySQL client is gonna use this one. And then we'll include something lib MariaDB as well. And this provides the development headers and static libraries for MariaDB, MySQL client. So basically MySQL client needs these to compile against the underlying MySQL C client library. And then at last we are going to clean up the apt cache after installation to reduce the final image size. So for that we'll write something like this. This is the command to remove the cache, and we'll give the location. Now once this is done, we are going to copy because we have mentioned all the packages in the requirements.txt file, right? So we have to copy the requirements.txt file into the container. Now whatever Python dependencies we have mentioned in requirements.txt file, we need to install all of that. So here let me write the command first and then I'll explain. So here no cache dir, it prevents PIP from storing downloaded packages, reducing image size. And then upgrade PIP, this should be upgrade and not update. So upgrade PIP, yes. So upgrade PIP is kind of ensuring PIP itself is up to date within the container. And then this one is for installing all the packages listed in the requirements.txt file. Now we'll go ahead with stage 2 and build the final image. So this stage is going to create the final smaller production image, and it will only include the necessary runtime components, not the build tools from stage 1. Now we'll again set the working directory. And then we need to copy the installed Python dependencies from the build stage, right? From this stage, from build, we're giving the location where it is supposed to copy. And then we'll copy any executables like, Gunicon installed by PIP. And we have to keep it in caps. Now we need to copy the Django project into the container. So here we'll just type in to copy all the folders from the project. Then we need to expose port. So this indicates that the container will listen for connections on port 8000 where our Gunicon server will run. And at last we have to run the Django application using Gunicon, right? So we have to provide a command for that, and that command is also going to be the default command that will be executed when the container starts. So here we are mentioning command and then Gunicon, which is the server executable, and then we have to mention we have to specify the WSGI application to serve. So here we have to mention the project name. So let's give it a name as, I am naming it as my project.wsgi and application. So here my project is the Django project name, and WSGI is the module, and application is the WSGI callable. And then we also have to provide, we have to write something like this, which is going to, let me write it first. So it should be hyphen bind. So this basically tells Unicorn to listen on all network interfaces, right? So this is important for Docker, as containers have their own internal IP addresses, right? And we should also set a timeout for worker processes. So here let's give this as 300, and then we have to mention the number of worker processes as well, like, which is to be run. We have to mention it like this, worker. So this basically workers 3 specifies the number of Unicorn worker processes to run, and you can adjust this based on your server's CPU cores and expected load. So the Docker file is ready, and now let's just go ahead and run the Docker build command. So Docker build, and we'll tag it with my backend app, and then I'm not going to give a any specific version. I'm just going to type in as latest. So there's a dot missing here, so this is one, and then the other error is at, I think this is fine. That was it. There's a typo over here, and let's just save. And also there's a typo here as well, so I'll just write the correct one, and that should be it. So these two were the additional errors that we had. So let's go and quickly check this. Okay, this should be actually this and not 2.2, so now it should be fine. Now it should be able to successfully build the image. Alright, now if we go to Docker, and if you see the under images, you'll be able to see the my backend app image as well, and also under builds you'll be able to see this one. Now I'm going ahead and creating 3 repositories, one for my front end, and then I'll create another one for my backend. And then I'll go ahead and create a separate repository where I'll be keeping my Docker Compose YAML file, and any deployment related GitHub Actions workflow will actually eventually reside in this one. Now let's just push our code to Git. So I will go to the front end first. I'll first initialize Git, then we'll add all the files to the staging area. Then let's commit the changes. Now we'll push the code to the main branch. And from the front end app, we need to copy this, and then here git remote add origin, and then we need to push on this repo, right? So git push origin main. Now here if you see, I have all the code into GitHub. Now we'll go ahead and push the code to the backend app as well. From here we'll copy this. Let's just then git commit initial commit backend app. We have to push to the main branch, right? So now git remote add origin, and we have already copied the link, and then we'll push the files. Now here if we refresh, we should be seeing all the files. Alright, so we have our front end and back end code in GitHub now. Now let's just go ahead and set up the third repo. So I'm going ahead and cloning this repository into a new VS Code window, because I want to create a compose file which kind of orchestrates everything front end, back end, and the database. So let's just go ahead and do this. So I'll copy the link, and here I'm going ahead and opening a new window. We'll clone the repository. Now let's create a file here. So this is where we are going to keep all the steps in the YAML file. Okay, so let's just first understand that why did we create this file. Till now we have built our own individual Docker images for the front end and back end. Now how do we get them all run together along with our MySQL database in a cohesive environment, right? And that's why we are writing this file. So this file is essentially a blueprint for defining and running multi-container Docker applications, and it allows us to orchestrate all our services with a single command. So let me go line by line, and I'll explain you what do we have. From just by having a look at it, you can understand that okay, I have mentioned all the services here. So we have front end, we have back end, and then we have database. So this version here simply specifies the version of the Docker Compose file format we are using. Version 3.8 is a recent and widely supported version. That is why I have given it as 3.8. And the core of the file is of course the services section. So the services section is where we define each individual component of our application stack. Okay, so think of each service as a separate container that will run a specific part of our application. Okay, so we have 3 main services services here: frontend, backend, and DB. So the first one that we have is frontend, which is this service is React app with engines. Okay, so this section defines our React frontend service. So here build then /my frontend app. So this tells Docker Compose to look for a Docker file inside the my frontend app directory. Okay, so relative to where this Docker Compose YAML file is located, and build our frontend Docker image from it. This is where our React app gets compiled and packaged with engines. And then this is crucial mapping. So basically it means that port 3000 on your local machine will be mapped to port 80 inside the front-end container. Okay? And since engines inside the container serves our React app on port 80, you will be able to access your React application in your browser by going on to localhost 3000. And restart always. This is a handy setting that tells Docker to automatically restart the container if it ever crashes, or if it fails for any reason, it will always restart. So this keeps our application resilient. And this line sets the environment variable inside the front-end containers. Our React application's code will read the React app backend URL to know where to send its API request. So here if you see, we are using 8000, this is the link that we are using, right? Backend 8000 API. So within the Docker Compose network, backend is the host name that refers to our backend service container. Okay, so this allows the front end to communicate with the backend seamlessly inside the Docker. Now this will be in a separate container. So this is backend service, which is Django API with Unicorn. Alright, so here in the first line, by first line we mean that similar to the front end, this tells Docker Compose to build our backend Docker image from the Docker file located in the my backend app directory. And this image will contain our Django application and the Unicorn web server. And this is again the port mapping. So this maps port 8000 on your local machine to port 8000 inside the backend container. So this allows you to directly access your Django API, right? So for example, your local host 8000/API/products from your browser, or tools like Postman. So this is just that mapping. So now this block is very important for configuring our Django application at runtime. Okay, so here MySQL database, whatever information we have given, right? Database name, then user, password, host, and then port, right? So these are the credentials and connection details that our Django application, specifically like settings.py file, right? Wherever you would have mentioned your DB details. So it will read from its environment to connect to the MySQL database. So if you notice here, if this one, right, MySQL host, we have given it a name as DB, right? So it is like the service name of our database container within the Docker network, so allowing the backend to find the database. So with this name, it is going to find the database. And this one, if you are just locally testing your application, you can give like a random normal key, but for production you should be creating a very strong randomly generated and secured managed key, and you can keep it as your Django's secret key. And here right now I have given star, that means it is going to allow everything, but this is only for the local testing, and for production this should be restricted to your actual domain names for security. And then at last we are keeping the debug mode as true. For local development to see detailed error messages, this must be false in production. You don't have to keep it as true. And then we have this section depends on. So this tells Docker Compose that the backend service should only start once the DB service is fully up. So because the backend is dependent on the DB, if the DB is not up, the backend is anyway not going to give us any result. So that is why we have this section of depends on, and it is going to check whether the MySQL service is fully up and healthy or not. As I said, this prevents the backend from trying to connect to a database that is not ready yet, right? Avoiding connection errors. And then again, restart always. This is just like the front end. This ensures that backend container restarts if there are any failures. And then finally, we have the third container, which is going to be the DB service, MySQL database. So this one, right? Instead of building this from a Docker file, we are actually using an official pre-built MySQL Docker image directly from the Docker Hub. This saves us the effort of setting up MySQL ourselves. Okay. And then in the environment section, we have set these 4 important information. So here MySQL root password is going to set the password for the MySQL root user, and then MySQL database, my database, it is going to instruct MySQL to create a database with this name. Okay, so these are basically instructions, right, that we are giving. So in the DB container, this is what it is going to create. It is going to create a database with this name. It is going to give this a password as whatever you actually provide here, right? You can change it. Like for now, I have just kept it something, but you can keep any specific password that you want. And then this is going to instruct MySQL to create a user with these credentials and grant them access to my database. So this is the information that you're giving to these are instructions that you're giving to the container. Okay, and that is how it is going to set this up. And then we have this volume file, and in simple words, if I explain you this is so for example, let's say if you stop, remove, or recreate your DB container. Okay, so your actual database files, your product data will persist on your host machine in the DB data volume volume, so you don't lose any data, and that is why we always give the volumes. Okay, so this is extremely important for database persistence. So it creates a named Docker volume called db data. Okay, so it is going to create a volume named db data and mounts it to this folder, okay, where lib and MySQL, and inside the container, it will be inside the container. So this means that even if anything happens, or if recreate your db container, you stop or you remove it, you are not going to lose your actual database files or your data. Then in the health check, this blocks define how Docker Compose determines if the MySQL database is truly healthy and ready to accept connections. Okay, so it runs a command of MySQL admin ping periodically, and that depends on the backend service, and that depends on inside the backend service is going to use this health check. Okay, and then at the end we are explicitly defining the db data named volume that we used in the db service, right? So this is where Docker stores the persistent data for our MySQL database. So I'll save this file and I'll push it to GitHub. I'm just going to commit these files. Let's copy this link, and the commit is done. Now that our code is in GitHub, now let's proceed with step 5, which is container registry setup using AWS ECR. So this step will get your Docker images into cloud-based registry, making them accessible for your automated deployment pipeline. Okay, so for this, either you can use Docker Hub, but I'm going to use AWS ECR. So AWS ECR is AWS Elastic Container Registry, and it is needed to securely store, manage, and deploy Docker container images within the AWS ecosystem itself. So you can think of it like as a central repository for storing Docker images, making it easier to manage and share them across different environments. Okay, and it also supports both public and private repositories, allowing you to control access to your images. So in order to get started with AWS ECR, these are the prerequisites. So first of all, we are going to set up an AWS account. So we should have an active AWS account, and after that we'll also install AWS CLI command line interface. Once we have both of these things, we'll go ahead and set up the ECR repositories, and then we will authenticate Docker to the ECR repository that we have created, and after that we will be pushing our front-end and back-end images to the ECR repository. And once that is done, if we move to our AWS console ECR repository, we should be able to see our front-end and back-end Docker image over there. Alright, so let's just go ahead and get started with these two steps first. So if you don't have an AWS account, you can navigate to AWS and then you can sign up. I've already created an account, so I'll just go ahead and sign in. So now we have an active AWS account. Now let's just go ahead and install AWS CLI. According to your system requirement, you can install the respective CLI. So I've downloaded. Now I'll go ahead and install this. So now we have an active AWS account and we have also installed AWS CLI. Now we need to configure AWS CLI. So in your local machine, you can open your terminal, type in AWS configure. So now it is asking for AWS access key ID, and in order to get this, what you can do is you can navigate to IAM. Just type in IAM over here, and then you need to navigate to users. So right now I don't have any, so I'll go ahead and create one, and you can give any name. Also, you don't need to check on this checkbox because we are creating this user specifically for the programmatic purpose. Okay, so this user does not need to log into AWS. All right, so that is why we are not going to check this box. So here we are going to select this one so that we can only give the permission which is required for this user. Alright, after this, once you click on this, you will see a set of permission policies. Here just search for ECR. So I'm not seeing the one that we need, so we will directly try to search for the policy that we need, and this is the one. And just select this checkbox, click next, and that's it. You can click on create user. Now let's just go ahead and create access key, and then here is the option command line interface. Okay, you plan to use this access key to enable the AWS CLI to access your AWS account, and this is the one that we need. So I'll just click on this, just give the confirmation and click on next, and then let's just hit on create access key, and that's it. And this is the access key that I'm going to copy, and I'll go back to the terminal and provide this. And then so this was the ID, right? Access key. Now secret access key, I'll just copy this, I'll go back to the terminal and provide this as well. So for the region, if you see right now it is selected to global, but you cannot keep global in the setting. Okay, you cannot deploy to global, so you have to select a region from this. Okay, so once you actually spin up your EC2 instance, by default it is gonna select a region, but because we haven't done that yet, so it is still showing us global. So come back to your EC2 tab, like from here just click on find EC2 and come to EC2 and see, like, what is enabled by default. You can just select that one. So if I click on here, I see this, right? US-East-2. So this is what I'm going to set it as, because this is something that is going to be enabled by default. So here I'm just going to mention US East 2. and here we need to mention JSON. Enter. Okay, so we are done with signing in into the AWS account, and we have also installed AWS CLI, also configured it. Now let's just go ahead and create ECR repositories. For that, we'll navigate to ECR, and here we'll go ahead and create repository. And while you're doing this, you have to make sure that you're in the same region that you have set it up, okay, in the CLI configuration. So for each repo, we are going to set separate repositories. So I will create one for the front-end app, and you can leave all the other settings, like, whatever is selected by default as it is, and let's just go ahead and create it. Then we'll create another one for backend. So here, I mean, if you're confused that why we have only created for backend and frontend, and why did we not create a repository for database, the reason for that is because when Docker Compose runs either locally or even on this EC2 instance that we would be creating, it will automatically pull the MySQL image directly from Docker Hub. So there is no need for us to host a copy of it in our private ECR. All right, your setup with ECR repositories only for frontend and backend is perfectly correct. Basically, we need to only store the images that contain our custom application code. Now let's just go ahead and authenticate Docker to ECR so that we can push our images, front-end and back-end images, to this repositories. Now in order to authenticate, you need to go back to your terminal, and here you need to run this command. And in this command, there are two things that you have to replace. So if you see this, your AWS region, so you need to mention your region here, and also in AWS account ID, you need to click on your username here, and from here you can see your account ID. Okay, so just go ahead and copy this, and then we need to give the region again over here, and login succeeded. Now you need to move to your specific folder location. All right, so for that I'll move to my front end location, so users. Now we need to tag the image for this app, and then we have to push it to ECR. All right, and in order to tag the image, we have this command, and again we have to do few things here. Just replace your AWS region here, and then the account ID, and let's just hit enter. Now let's just refresh and open this front end and see if we have any image here or not. This is because we have only tagged the image, right? We have not pushed it yet. So let's just go ahead and do that. And in order to push the image, we have this command docker push. So here again, you need to give your account ID and your region, okay? Alright, so this is done. Now let's just refresh this, and we can see the image, right? The latest image over here. Alright, so now we have to do the same for backend as well. So we will navigate to the backend folder first. So here I have both the folders in the same location. So backend, and then we need to tag the image. So this was tag, and then here I will just change the name backend, and the region is same, account ID is same. And then we'll just push this. So docker push. Here also I'll just change the name because the name is backend, and that should be it. Make sure that you are mentioning your correct region and account ID. All right, so and enter. Alright, so now let's just see if we have the images here, and yes, we have the backend image here as well, right? This is what we tagged it to, right? Latest, and this is the image that we pushed. So now we are done with all these steps. We have an active AWS account. We also configured AWS CLI, and then we created ECR repositories. We authenticated Docker to ECR. We then tagged and pushed our front end and backend images to ECR, and after that we could also see the images, the latest tagged images that we pushed in the ECR repositories. Alright, so now let's just go ahead and do the next step, which is cloud deployment automation using AWS EC2 and GitHub Actions. So for this, we need to first launch an EC2 instance. So let's just move to AWS and launch the EC2 instance. So now from here, just move to EC2, and then click on instances. This is some instance that I already have, but if you have not created any instance, then you will not see anything over here. Or even if you have an older one, I think for this particular session, you can just launch a new one. So you have to be in the same region, right? Whatever we have set it up till now. So now let's just go ahead and launch the instance. Let's give it a name, and also this is free, so I'll just go ahead and choose this one. And again, for this also, you can just choose T2 micro. So for this one, if you have already created one, you can just select the existing key pair, and if not, but this is very crucial, okay? You need to create one. So I already have one, but let me just go ahead and create another one. So we can create new key pair, and you need to select RSA and .pem, okay? And you can give it a name, like anything that you want, and that's it. Let's just go ahead and create key pair, and then it will also give you a PEM file, okay? You need to keep this somewhere safe so that, like, you remember where your PEM file is. All right, so and then you select that key pair, like the one that you just created. It will automatically get selected, and then in the network settings, just click on edit, it, and then so VPC is selected, and then in the subnet whatever is available in your local region according to whatever is selected here, you can just select any of these. So the region that I have here is US East 2, right? So you can select any of these. So I'll just go ahead and select this one, and then auto assign public IP should be enabled, and because this is going to give your instance a public IP address which is going to be accessible over the internet from anywhere. Okay, and then in firewall security group, so we can create one for this. I will give a different name to this. Let's just give our own description. Now here let's just add more rules. I will add one for HTTP. So HTTP and TCP 80, this should be fine. And in the source type, it should be anywhere. Okay, so we have added one for HTTP. Let's just also add one custom, and we'll give the port range to this, and source type will be anywhere, so that it will directly give access to your backend API, right? So for the front end, you will get the access to backend, right? This will be helpful if you are debugging or trying to do some sort of debugging. Then let's just go ahead and launch the instance. Alright, so we have our instance now. Now when you navigate to EC2, and if you click on instances, you should be able to see your instance, and this is the instance I just created, right? My full stack app server, and this is not active yet. Maybe it will take few seconds, but it's gonna, it will start showing you running in some time, and now you can see that it's running. So now as we have our EC2 instance up and running, that means our virtual server in the cloud is ready. Now we'll go ahead and connect our EC2 instance and install the necessary software, for example Docker Compose, that will allow it to run our containerized application. So now we'll go ahead and connect to our EC2 instance via SSH. Now remember the PEM file that we that got downloaded, so we need this PEM file now in order to SSH into EC2. So we'll go back to the terminal, and you need to know the location of this PEM file, right? So for me, the downloads folder itself. So here, so this is the path for my PEM file, and the name of the PEM file is my app ssh. Let's just enter. Alright, now we have to set the correct permissions for the key pair file. Okay, so for that we need to run this command. So 400 means that only the owner can read the file. Okay, no one else, not even root user, can read, write or execute this file. So we'll run this command, and then actually we could have directly run this command providing the path, but let's just do this again. Let me try and copy this and enter this, and we'll allow. Okay, now we should be able to SSH into our EC2 instance. Okay, and for that we have this command SSH the path to the PEM file. Okay, so this is the path to the PEM file, and then using this PEM file we will go to, so here we need to give the public IP address of the instance. So if I go back to the instance, this is my instance, right? This is the one that we created. If I click on this, one second, why was it showing? Okay, this is running, right? And if I click on this instance, this is the public IP address that we have, right? So copy this and go back to the terminal, and here we need to give the IP address as well, and then let's enter, and I'll say yes. So here the one thing that could be wrong is because I think I had selected Linux. So let me see the user. So in order to correctly check the user, what you can do is just select the instance, and if I click on connect, so I had selected Amazon Linux. Okay, so that is why the user is EC2. Okay, so and here if you see in my command, I have typed in Ubuntu, right? So that is not correct. So let's just go ahead and change this. So, and that's it. Now if I run this, I shouldn't encounter the permission denied error. Yes, so it worked, right? So now you can see that I have this tag over here, right? EC2 user. So that means I have successfully SSH'd into my EC2 instance. Okay, so I can run any command from here now. So two things. Okay, so either you can SSH into your EC2 instance from your local machine the way I just did, or what you can do is you can just directly connect and then run any commands that you want on the virtual machine itself, right? So if I click on connect, it is going to, you can in the EC2 instance itself, you can run any command if you are. So here now the next step is to install Docker and Docker Compose. So I'll just go ahead and proceed from here itself. So here we'll first check for any updates. Okay, so for Linux 23 this is not gonna work. Okay, so we need to write we need to run yum command. So I will just find the update using yum command. Now I'll go ahead and install Docker. So for that we again you can use yum command itself. So install and then for any option, yes, and then Docker. So once the Docker is involved, we have to start and enable Docker service. Okay, this is complete. Now we can go ahead and start the Docker service first. And then we have to also enable it. So enable Docker. Now we also need to add our user to the Docker group. Okay, so the EC2 user that we have, right, we need to add that user to this Docker group. So for that, so the commands that I'm writing, if you're familiar with it, then it's good. If not, then I'll just try and brief you a little bit. So for example, this one that I'm writing, right, sudo user mode -ag docker ec2 user, right? So for example, every time we are writing sudo, right, it means that this prefix specifically stands for super user do, or you can say any sort of substitute that user do. So it allows a permitted user like ec2 user, right, on Amazon Linux, which is just allows to execute a command with the privileges of the root user, the super user. Okay. And this user mod is nothing but the user modify. So this means that the command line utility used to modify a user's account information. Okay, so this is, so whenever you are modifying any user account information, you have to use user mode, which means user modify. And then here what you see as -a, this means that it is just like an option for user modify. So when used with -g, it tells that user mode to append the user to the specified groups. Okay, so -ag, so it is like appending it to the group. And then at last, ec2 user, this is the target user that we want to modify, right? In this case, it is the default user on the Amazon Linux ec2 instance. Okay, so but this is the one that we want to add to the group. So let's just enter, and this is done. Now we also have to install Docker Compose, and we'll get the Docker Compose plugin library directly from here. And then we also need to make it executable, and then we'll create a symlink, as in the symbol link, like which is going to be acting like a pointer, as in like the shortcut for the file. So this is done. Now let's just check Docker Compose version out. So now you can see the Docker Compose version. All right, so now we have the EC2 instance ready, right? Because we installed Docker and Docker Compose, right? Because we needed that in the EC2 instance to run our Dockerized applications, right? Now where do we have our images? We have our Docker images in the ECR, right? That's what we did in the previous step. We pushed all the Docker images to the ECR. So the next logical step is to ensure that it has, your EC2 instance has permission to pull your images from ECR, okay? And then to get your Docker Compose YAML file onto the instance to orchestrate the deployment. Now there are two ways to do that. So either you can configure your AWS credentials directly into your EC2 instance, which is not secure. So the best way is to attach an IAM role. So in AWS there is something called IAM role. So we can go ahead and create one specific role that will grant the necessary permission to pull images from the ECR repositories. So let's just go ahead and do that. So from here I will type in IAM. So we'll go to IAM, and then you need to go to roles. So there are several here. There are already 3 roles. I think I created it for some last instance. So let's just go ahead and create a new one for this, and you need to select AWS service. In the use case, you can select EC2, and then let's just click on next. And here we need to search for Amazon EC2 container registry read only access. Okay, we'll give only read only access. So EC2 container registry read only access, and then let's just do next. And here we have to give the role name. Okay, so in the role name you can give something as anything, whatever makes sense to you. And here we have to give allows EC2 instance to pull images from ECR. That is why we are creating this, right? And that's it. Let's just create role. So this is the one that we just created, right? Now we have to attach this IAM role to our EC2 instance. Okay, so we'll go back to EC2 instance, or we can just do it from here itself. I mean, we don't have to do it from here. So let's just go back to EC2, and then let's just go to instances, and this is the one where we want to attach it. And here under actions we should have something as security. So under security, modify IAM role. Okay, and here we will select the role that we have just created. Okay, so here in IAM role, we'll refresh this once, and this is the one that we created, right? So I'm going to select this role and then update IAM role. So here in the Docker Compose YAML file, whatever settings we had was according to the local setup. Okay, but for production you have to pull the images from ECR, right? You are not directly going to this directory and then trying to run or build anything. Okay, so here we would have to change few things. So here now we don't have to build. Okay, so we are going to rather pull the image from ECR. So here you need to give your AWS ID here and also your AWS region. Let me copy the AWS ID, and the region is this US East 2. So we will be pulling this image from ECR. All right. And here let's map container port 80 to host port 80. All right, so this should be 8080, and restart always is fine. The environment is React backend, URL is still going to be the same. So because this is still going to be the service name within the Docker Compose network, right? So this is fine. And then in the backend also, rather than build, we have to use the image from the ECR repository. So here let's just copy the AWS account ID and also the region. Then port is fine, and these things are fine as well, but here we need to create a Django secret key. Okay, and what we can do is we can go to our backend project. So whatever we have, this is my infra, right? So we'll move to the backend repository and we'll create a Django secret key. So there's a command to create a secret key, so I'll just move to that folder first. So this is a command to create random secret key. So this is what we are importing, and we are using it to, this is a function, okay, which is going to give us a random auto-generated key. I think this is not from bash, so let me try and run it here under this. No, not this one. Let me try it here. So here we got the random generated key. So I'll copy this and I'll go back to the infra. And here in the secret key, we are going to paste the key that we have now. All right, and then what else? And in the debug, we'll set it to false, because in the local we set it to true so that we can, like, check out the debug logs and everything. We don't need to generate all of that here, because this is, we are prepping this for production, right? So okay, this is fine. And what else? I think we are good with this. Just one more thing. In Django allowed host, you can we can give our actual domain in production that we have, right? So but right now let's just leave it like this. Okay, and then we need to deploy this. Now we need to get this file into EC2, okay, because we have not set up any auto deployment yet, right? And right now we only need this file. So let's just go ahead and get this file into EC2 instance. So we'll just go ahead and clone this repository into EC2 instance. So we'll go back to the instance, and first we'll install Git here. So Git is installed. Now we can go ahead and clone that infra repository. Okay, so let's first navigate to the home directory. I think we are at that folder, but let me just do that. So here we'll type in git clone, and then we need to give the path. So if I come here, this is my repository. So I'll move back here and then here. So here you have to be on here, right, on your project. So we'll copy this, and then I will go back to the instance and then paste it over here. And it is done. Okay, now let's navigate to the repository. So it is my project infra. So we are under this folder now. So now we are ready to use Docker Compose to pull our images from ECR and then start the entire application stack on this EC2 instance itself. Okay, so now let's just go ahead and run Docker Compose on this EC2. So we'll first run the Docker Compose service in detached mode. So let me type that first. This command tells Docker Compose to read your Docker Compose YAML file, okay, and it will then pull the specified Docker images, as in our front end and back end images, from ECR, right? That is where we have kept it, and MySQL from Docker Hub, and then it will start the services in the correct order. Okay, it will start the database first, then backend, and then the front end. And the -d here, this flag runs the containers in detached mode, meaning they run in the background. Okay, and you get your terminal prompt back. So let me try this first. I think after Docker I need to put a hyphen, but yeah, so I think I had to put a hyphen after Docker. Here I'll put a hyphen. So although we had given the authentication via role, right, it is telling that, like, it's like we have a problem in, like, Docker authentication of ECR into EC2. So what we can do is we can authenticate again. It's just one line of command. So again here we will give the region and also the AWS account ID, and we have to specify the region here as well. So let's just do that. So login succeeded. Now we can go ahead and run that command. Okay, this one. So this generally means that the image that we have, right, the image that we have pushed for the front end and back end, that doesn't have a version that is kind of compatible with the EC2 instance over here. Okay, so we need to build multi-architecture Docker images. Okay, and for that we need to install just one more additional thing for Docker. So first I'll go to my terminal, and here I think I would have to log out from this. First do it for the front end. So here, okay, this is fine. So here US is true. All right, let's do this. So this is also automatically going to push the image as well. Okay, it is going to build and push the front end app image. So once this is done, we'll have to do the same for backend as well. All right, so this is done. Now let's just do it for backend, and then same step. I'll just change the name of the app. Okay, so backend here, and I think that's it. Although I think this should have already been done, but let me go to the instance and check in ECR. Yeah, so this got updated, right? If you see, this got updated, and let's check the backend one. So this is still running, right? It is not updated yet, so let it complete and let me refresh this. So yeah, this got updated as well, right? So now the new images for backend and frontend are pushed into ECR. All right, now here we'll rerun the command and see what happens, and see, it's pulling now. It is able to pull the images from ECR now. It might take few seconds, all right, to get completed. So here, if you would have observed, I mean, the backend didn't start until unless the DB was up and it was tagged as healthy, right? So now this is all good. Now we can go ahead and do the next step. So now we need to, we are done till here. We need to run Django migrations on EC2. So when your MySQL container starts for the first time, basically it's an empty database, right? So your Django application needs to create its tables, right? For example, if it's like product database, then it has to create tables for product, users, or sessions, etc., right? Within that particular database. So we need to run migrations on EC2 for that. So let's just go ahead and do this. So here you need to be, if you are doing it from your local terminal, then make sure that you are under this folder, my project infra. Okay, so first thing is that you should be SSH'd into your EC2, and then you should be under this folder, after this, whatever you run. So I'm going to run here itself. So first, let's just verify the Docker that's running, as in let's just verify the containers once, and these are the containers that we have. Okay, so we have front end, we have back end, and then we have the InfraDB as well, and all are up, all three are up. Okay, so these three things you need to check. So you need to check the containers that are up and running. Okay, now the next step is to find the ID of your backend container. So which is the backend container? This is front end, this is DB, and this is the backend container. Okay, and the ID for this is this one, container ID is this. So let's just copy the container ID. I think I'm able to copy it like that, Control C, and then to run the migration, so Docker execute, and then backend container name or ID. Okay, and I've copied the ID, this is the ID, and then Python manage.py and then migrate, because for the table and database creation, everything, we have it over here, right, in manage.py. That is why we are referring to that. All right, so this is done. Basically there are no tables and anything, right? I mean there is no data, real data. That is why it says no migrations to apply, but then it would have created the tables and everything. Now let's just go ahead and test it out. I mean, if we run our if we check out our public IP address that is given on the instance, we should be able to see the application. So let's just check that first. So we'll go to EC2, we'll go to instances, and then this is the instance, right? So let's just go here, and this is the address that we have. So maybe let me add some products. Okay, so I'll go here, and I need to give my public IP address here, so I'll copy this and here. So as you can see, it is asking us to add the IP address to the allowed host, right? So we'll go ahead and add it to the allowed host. So what is the IP address that we have? This is the one, right? So I'll copy this, and let's just go to our YAML file. Okay, so I'll go to my YAML file. So in the YAML file, we need to add the IP address over here, and I'll add couple of other things as well. So this is fine. So we are adding the public IP address that we have. We are also adding backend localhost, and then this one, the default one. And also here in the backend URL, right, we need this now, because we are doing this for the production, right? So this is the public IP address that we have, so we need to change this as well. Now let's just save this, and I'm going to push this file using my terminal into EC2. So this is still not opening, and also the admin panel, right, from where I can add the products, this doesn't seem to be working. So what we can do is, let's just go ahead in EC2 instance and check the content of the compose file. We need to navigate to that folder, right, where this file exists. Now let's just check the content of the file. So this is the content of the file, and allowed host does include this. So this looks fine. Now let's just check the containers one more time. So all the containers are up, and then we can run this command to inspect. And what is the backend container ID? This is the backend container, and this is the ID. Let's copy this and paste it here. Maybe something is wrong in so the allowed host looks fine, right? So maybe there's something not right with the settings.py file, right, inside the backend container. So we need to open a shell inside the backend container. For that, docker exec, and then we have to run an it command and then backend container ID. So this is the backend container ID, and then bash. Now let's change to the folder. Now let's check the file cat settings.py. So here also we should have something as allowed host, and alright, so looks like this is course allowed host. Yes, this is blank, right? Here also we need to allow the host, right? So this is the problem then. So now let's just go to the settings.py file. We need to go to my project settings.py, and here allowed host, we'll put a star over there so that it can allow. Here git add, and then I'll add this file again, and then commit, and git push origin. So now we have to build again and then push it again, right? So docker build x command, this was for backend, right? Perfect. So this is the one that we need to run again. This is going to rebuild and then push the image again. Okay, this is done. Now we'll go back to the EC2 instance from here, and we will go back to that folder, and then we will pull the latest backend image. Okay, so actually we need to exit the shell first. Okay, so because we were inside the, if you see here, right, root @ so we are inside the backend docker shell, right? So we have to exit that first, and then from here we can run that command. Once this is done, we have to restart the services to pick up the new image. So we will let it complete, and then we can, yes. So now we can run docker compose down command. So we'll start the new container with new image. And now because we have removed the container and then created a new one, right? So that container will have a new container ID, correct? And that is why we would have to run the migrations one more time. So for that, let's just first run docker ps and get the ID of the backend container. So this is the ID of the backend container, right? So we'll copy the ID, and we'll look for that docker execute command, the migrate command. This is the one. We'll just paste this new ID. All right, now I'm going ahead and creating a super user. As I mentioned before, I mean, if you want to, then create it, otherwise it's optional. So I'm going to, here also I have to give the new container ID. I'll give the username as root, email address I'll skip. Now let's just go ahead and check the Django admin panel and see what happens. So here I can, now I'll be able to log in, right? So here the username was root, I'll enter my password, whatever I had given there, right? So let me log in. Now here you can see, like, you know, I have these were the two products that I had initially added. So now you can see that the app is live on this public IP address, but the deployment that we have done till now is totally manual, right? So I was installing everything by going on to EC2 instance, and also I was pushing all my files from my VS Code to EC2 using the terminal, right? So I was SSH in using the terminal, and then I was doing whatever I wanted to do, and from my local terminal, from the command line, I was pushing any files that I wanted to push to EC2, right? But then let's just go ahead and check out how we can automate this deployment using GitHub Actions. All right, so once we set up CI/CD pipeline, we won't have to manually deploy every change every time following multiple steps. We will just push any change that we do in our VS Code, and if we commit anything to the main branch, the deployment will get auto triggered. So these are the steps. So we will first create GitHub secrets, and then we will generate access keys in AWS. We'll get the private key, and then we will set up the GitHub. All right, so let's just go ahead and start with creating GitHub secrets. So for the deployment, we are going to create a new IAM user. All right, so that particular user we'll be using for the deployment. So we'll move to IAM. I'll click on users, and here we can use the user that we created earlier, right? So let's just click on this user, and we'll go to security credentials. So here I can only see the access key ID, but I also need the access secret key. And when we create the access key, right, I was supposed to store the access secret key if I was planning to use it later on, but I had not saved it. But that's not a problem. We can go ahead and create a new access key, and then immediately we will also get a secret key as well. So I'm going to use the same user, but I will not use the access key that I had created earlier. I am going ahead and creating a new one, and we will choose command line interface. Let's confirm, and then next. let's just say deploy CI CD and then create access key. All right, so this is the access key and this is the secret. Okay, and you need to, when you are doing this, right, just save it somewhere, because it will not, like, once you go back on that screen, it is not going to show you the secret access key again. So at least I did not find any tab where it was showing me the secret key again. So access key and secret key, so I'm just gonna copy both. Access key I will get it later as well, but still I'm just gonna copy both of them, and then I'll copy this as well, and I'm just keeping it somewhere else. All right, so this is done, and I'm not sure what does the CSV file will have, but let me just hit download, and I think, yeah, it has the access keys, and I'll just click on done. All right, so in order to set the GitHub Actions, we need three things. Okay, so we need the access key ID, the one that we just created, and then access secret key, and then also there's the third thing that we need is the PEM file that we had created earlier. Okay, so whenever you download your PEM file, do not delete it, just keep it with you because you will be needing it later on. So I have my PEM file inside my download folder. So if I go to download, so this is my PEM file and I have it. So if you are using Windows, maybe you'll probably be able to open your PEM file directly, but if you are using Mac, you are not going to be able to, like, open your PEM file. Okay, so you can rather use terminal in order to copy the content. So I'll navigate to my terminal and I will switch to the downloads folder. Then I would have to set the correct permissions, and then I can run a command to read the content of the file. Okay, so my app ssh.pem. Alright, so here this is what I need to copy. So I am going to copy everything from here till here. So I have copied this. Now we have all the three things that we needed. We have the access key and we have the secret key from the user, and then we also have the PEM file content. Now we'll go to the GitHub, and under the my project infra settings, we need to go to settings, then go to secrets and variables, and then under actions, click on create new secret, and here first I'll copy the content of the PEM file, and here I'm going to give it the name as EC2 SSH key. Okay, and then I'll click on add secret, and then similarly we need to create new secrets and store the other information that we require. So I'll click on new repository secret, so access key ID, and if I go back to this user, the access key ID, the second one that we had created, right? So this is the one, the new one that I just created, right? So I'll just copy the key ID and I will paste it here. Now we also have to add the secret key, right? So I'll click again on this and secret key, and this is something that I had stored, so I'm just going to copy that over here. Then we also have to add region, so I'll click on AWS region, and then here the region was, let me go back to the instance, I think it was US East 2, but let me just confirm. So instance ID and US East 2. So let's just save this. Then we need to add one more secret here, so this would be the EC2 host, and here we need to give the public IP that we have. I'll just copy this and paste it here, and then we'll create a new one for the user. If you want to verify which user it is, then click on connect and then you will see the user. Okay, so in my case it is EC2 user. Let's just save this, and then we need to add one more for AWS account ID. So I'll just over here, I'll copy the account ID and paste it here. So these are the only things that you need to add. So now if you see on this public IP address that we have from our instance, we have our app running. So everything is running now. The only, there are a few points that you have to keep in mind. Okay, so if you're developing everything from the scratch, as in if you're also developing front end and back end completely. So once you're pushing everything to prod, then you also have to change all the endpoints that you have in your front end and back end, right? So for example, in this one, there's one thing that you have to particularly check. So let's say if it doesn't work, right? So in your project infra file, right? So the React backend URL. So if you see here, I have given, before this I had localhost, right? But I had to update it to the new IPv address that is given by EC2 instance, right? So these kind of changes you have to update it, right? So here in your Docker Compose file, this is the production, as in this is the EC2 instance IP address that has been given, right? And apart from that, I think you should be good. You should be able to kind of run it. Now, as we are done setting up the action secrets and variables, let's just go ahead and set up the workflow. So for that, you need to click on actions. In the same repo, just go to actions, and we would have to use that secrets and variables in the workflow that we are going to set up. So you can leave all of these options and you have to click on set up a workflow yourself. So the moment you click on that, you will see this file main.yaml. You can also change the name if you want, but I am going to keep the same name. And herein we have to set up the workflow. So here we'll first give it a name to this. So I'll just give the name as CI/CD pipeline, and then we have to give the branch name. So whenever there is a change that occurs to the main branch, that is when I want to trigger this pipeline. And then we have to mention all the jobs that are supposed to run. This should be branches. Then we'll give build and deploy. We can take the Ubuntu latest. Okay, so we'll use the latest Ubuntu runner provided by GitHub Actions. So you can type in Ubuntu latest. Then we have to give the steps. So let's give it a name first. There has to be a space after this. Just type in checkout code and then uses. Basically the action to check out your repository code. Okay, so that's what we are mentioning here. So actions, and then we have to configure AWS credentials. So let's just do that. One space from here. So uses. This is going to be the action in order to set up AWS credentials with. Now remember all the secret and variables that we have set up. We are going to use that now. So we will use AWS access key ID and then secret access key, region, like whatever we have set up, we can provide in the credentials over here. These are the variables and the values that we have set up in the secret, right? So that is what we are using here. Now we need to log into Amazon ECR because we need to pull the images to run the containers, right? So that is what we will do next. Log into Amazon ECR, login ECR, and then we need to provide the action to log into ECR. Now we have to build and push the Docker front-end image, and then we have to build and push the backend Docker image to ECR. Okay, so here now we need to give the name, and for this we have to mention the environment first. And so to the React app we have to give the public IP, right, that we have from EC2 instance in the EC2 host. So for that okay, we'll be passing these three info. Okay, and the AWS account ID and AWS region we are taking from the secret variable that we have created. Now we have to run this. Okay, so in order to run we will do the same thing that we were doing via terminal. Okay, so if you just remember the steps, it will be easier to understand this. So run. For front end, we first need to navigate to the front end application directory, right? So we have to give that command. So cd, then my front end app. This is the directory that we have created. Okay, and then we have to build and push the front end image. So if you remember the command that I was running in order to build from the terminal, we have to give here the same command. So this command is going to build the front-end image and it will also push the front-end image to ECR. Okay, so that's what we are doing here. And then we also have to switch back to the root directory. Okay, so for that cd dot. So this is going to get us back to the root of the project infra. Then we are going to do the same thing for the backend. Okay, so we'll build and push the backend Docker image to ECR. So I'll just copy it and paste. So I have to be over here and let's just make a space, and this is not aligned, right? So let me just align it. Now we are done with the images, pushing the image, building and pushing the images to front end and for front end and back end to ECR. Now we have to deploy to EC2 via SSH. So whatever we were doing in the terminal, right, when we were deploying everything manually, the same instructions we have to write over here. Okay, so let's just go ahead and do that. And then under users we have to mention the action. So users, we'll mention action to execute command via SSH. Okay, so this is the action that we'll be using over here. And then we have to give all the variables that are required. So we need to give all the host, username, key and script also, right, in order for this action to execute. First we'll give the host dot, and then we have this secret, right, EC2 host. That is what we are going to use here. This is going to give us the public IP, right, for the GitHub secret. And then username, this would be EC2 user, and then the key, I'll copy the same thing, and this has to be EC2 SSH key. And then we have to give the script, as in line by line whatever we were doing, right? We would have to change the directory to my project infra, then we have to pull the main origin branch, right? And then we have to also log into ECR. We have to everything that we were doing, right? We were making the Docker Compose down, then we were pulling the latest images, and then we were again running the Docker Compose, right? So all of that we would have to write here in the script. So first we would have to navigate to the project, like my project infra directory on EC2, right? So we have this directory already on EC2, and then we will pull the latest changes from GitHub, including Docker Compose YAML update. Okay, and after that we have to authenticate Docker to ECR on EC2, right? That is what we are doing here. And then after that we would have to stop and remove any existing containers, pull new images, and then start the service. That is what we are doing with these three lines. So we are stopping and removing any existing containers, and then we are pulling the new images, and then we are starting starting the service in the detached mode. Okay, and then we are waiting a bit for backend to be ready before we start migrations. Okay, so we are just putting a wait over here, and after that we are getting the backend container ID because we have to do the migrations for the MySQL, right? And then once we get the backend container ID, we have to run Django migrations, and that's what we are doing here with this command. We are using the backend container ID to run the migration. And if you remember, I told you that this step is optional, so you can either create super user or you can also skip this, but this is the last step, and after that your deployment should be complete. So we are just printing this message that deployment is complete. So now we are done with this. Let's just save this and try it out, commit the changes. So let's just go ahead and, okay, 1 second, this has failed for some reason. I think that build command is creating issues because I think I have it in multiple lines. So let's just go ahead and keep it in one single line. Okay, and let's edit this. So I'm talking about this command. Okay, so I will rather keep it in one single line. Remove this and let's just keep it in one single line, and this should be fine. And we'll do the same with this one as well. Commit changes. It is still creating issues. So what we'll do is, let's just go back to this file. We'll go to the YAML file, and we are going to add something that which will make sure that it is going to execute the commands sequentially. So this is front end, and where is the build command? It's here, right? So here we can add something like this, which is going to make sure that it is going to execute the commands sequentially. And here also, after push dot, I'll add this, and similarly here as well. So we'll add this, and here also we will add this, and that's it. We'll commit the changes. Okay, the directory is not fine. So actually we would have to, let's just do one thing. We will check out all 3 repositories separately. Okay, so I'll go to main file, and here so in the steps here, if you see, I'm just checking out everything at once, right? So this is not working. So let's just check out everything separately. So for example, so here we will check out one by one. Okay, and here in repository I have to give the GitHub username. Okay, what I have. So here let me go to this is my GitHub username, so this should be fine. So let me put that here. I can give the same here as well now. So if you see the error, the problem is with this Buster release. Okay, so I will go back to my backend Docker file, and I will change the, let's use something else apart from Buster. So I'll go to the backend app, and here in the Docker file here, so from Buster I'm gonna use the bullseye, and let's just commit this. Okay, this just got updated, so this is fine now. Now let's go ahead to my project infra and just trigger a change, do a blank update here, and let's see. I think there's something wrong in my PEM file. I'll go back to the settings, and in the key, so I'll go back to secrets and variables, actions, and then SSH key. It's here, right? So let's just update this, and here I think this is what is wrong, right? It shouldn't, because in the terminal I could see also this percentage, right? And I think that's not correct, and this should be fine now. So let me update it, and then I'll go back to the YAML file, and we would have to trigger it again. Commit changes. Alright, so that .pem file content was the issue. Okay, so this is successful now. Now we have to build a workflow for front-end and back-end as well, right? Because this is only going to get triggered if there are any changes in the project infra compose file, right? So we are good with this. Now let's just go ahead and do it for front-end and back-end as well. So here there's one more thing that I want to highlight. So here, if you would have observed that we had multiple build steps, right? So here, if I show you, no, this is the Docker file. Let me go to the YAML file, the main deployment file, right? The workflow file that we have. So here we had multiple steps, right? Checkout code, but this is actually not working because the workflow exists inside this, so it is only able to detect the main branch changes for whatever is inside this directory. Okay, so I will remove it later, like the checkout for front end and back end. So we will rather do front end and back end inside those repo directories. All right, so I'll just move to my front end first. So from front end I'll click on actions, and then we are going to set up a workflow over here. So we'll do the same steps, but the thing is that we are only going to check out the code from the front end directory. All right, let's give it a different name. Okay, so build and push front end YAML. This is the file, and here I'll quickly explain what and all are there. So we are this is just the name that we have given, build and push front end to ECR. And then here, if there are any changes which are committed to the main branch, this workflow is gonna get triggered. Okay, and then in environment, same thing, right? AWS region and repository, whatever we have saved in secrets, right? We have saved all these variables and values inside secret, so that is what we are picking up from. And then in the jobs, we are taking this Ubuntu runner for each job, and then we are giving the permissions. And in the steps, we are checking out the repository, and this is the action which is going to clone the GitHub repository, right? The my front end app repository. And then we are configuring AWS credentials, and then we are using all these keys and region, like whatever we have available and is required over here. Then we will log into Amazon ECR, and then we are going to build and push the image to Amazon ECR. Okay, and then we are running the script. And here also, I think let's just, because in the previous workflow we were facing some issues, right? So we had to make it in one line, so I'm gonna do that here itself. So I'm going to make it in one line. So alright, so let's just commit this and make some changes in the front end. Commit changes. And then we would also have to add all the secret variables that we have added in this one, right? We have to do it. We have to do that for front end as well. So I'll go to actions. So I'll add, let's just save this, which was AWS region. Let's just add another one. Let's just give the access key ID, and the secret key I had already copied somewhere, so I'm gonna take it from there, but we would have to enter that as well. Secret access key, paste it here and then save it. SSH key, and then I think that should be in my terminal here. I'm gonna copy this, and then we'll remove that percentage from the end. This is not supposed to be copied. This is fine. Let's just add it. Paste the account ID here and then save this. Also, we need the EC2 host. Now let's go back to that file. So this has succeeded. Now let's just go and check the backend. So we will go to the backend folder, and we would have to do the same. Go to settings, and in the secrets and variables under actions, we would have to create all of those. And I think we should be good. So we are missing one, and add that as well. AWS account ID, sit here and add it. Now under actions, we'll go ahead and create a workflow. So workflow, the name here to backend. I'm just going to paste this code, and here I would have to change this to one line, otherwise it's gonna fail. It might fail, right? Let's just save this. Alright, so this is done as well, and here also we are doing the same thing. Okay, the only thing is that the repository is different. Alright, okay, so now we have the workflow setup for front end, back end, and also our project infrastructure repository. Okay, now let's just go ahead and do some change and see if all of this is automatically working or not. So here I'm gonna remove this logo, and this is on the public IP, right? I'm gonna remove this logo, and I will push it from my VS Code, and then we'll see if the deployment happens and if this is getting refreshed automatically or not. Okay, so I'll move to my front end, and I'll go to my app.tsx file, and here I believe this image, and this is the image actually, and I will remove this, and I'm going to deploy this. So once I've committed the change, I should be able to see it in the actions for front end, and once this succeeds, we should be able to see here, like this should be gone, like we should be able to see the latest changes. But then before this, we also have to run the project infra workflow, right? Because that is going to pull the latest Docker image, right? So I'll go to project infra. So here we can just run the workflow. Okay, this is done. Now if we go and refresh this, so see, now the logo is gone, right? So the changes are now automatically getting deployed to EC2 via GitHub Actions. So right now we can see the application on the public IPv address, right? So if we want to divert that to a domain name, like a real domain name, then there are two ways of doing that. Either you can purchase a domain from AWS itself, or you can purchase a domain from somewhere else and then navigate back to your AWS account and you can do the required settings. So I already have a domain, but let's just go ahead and first see that what is the first step that we need to do in AWS. So in AWS we have something called Route 53, and on Route 53 we would have have to create a hosted zone for the domain name. And once we create hosted zones, we have to note down the name servers that would be given after creating the hosted zone, and then we have to update those name server in the domain registrar's name servers. So let's just go ahead and do the first step. Let's just first go to Route 53 and create a hosted zone. But before that, I'll show you my domain name. So I haven't purchased a domain from AWS, but I have it from GoDaddy. So this is the domain that I have. You can purchase like a really cheap domain from here as well, or you can of course go with AWS and buy a domain from there as well. Here, once you go to your domain, you need to go to your name servers. So I'll go to my domain, and then under your domain name, right, you will see something as DNS, and under DNS you will see something as named servers. This is where you would have to update your name server record. So let's just go ahead and create a hosted zone. So I'll navigate to Route 53 and then click on hosted zones. This is one of my older ones, so we'll go ahead and create a new hosted zone. And here in the domain name, you don't have to include HTTP or HTTPS, you directly have to include the domain name. So I will just copy this and I'll paste it here. This will be public hosted zone, and that's it. Let's just click on create hosted zone. So you see here, the moment you create a hosted zone, there are few records that get auto created. So these are the ones that we would have to add onto the named servers. All right, so let's just copy one by one and add it there. So I'll copy this one, I'll go back to the named server and I'll click here because these are some older. I'm going to delete all of this. So we will add, so let me add the first one, and we don't have to include the dot here. So this is the first one that I have, and then let's just copy the second one. So we would have to add all of that one as well, and this one too. That's it. These four you need to add and then save it. So if you have purchased the domain outside AWS, then this is the only step that you would have to do. So after this, you will not be able to see your app directly on the domain. We also need to get the SSL certificate, because when you open any domain, you need to have HTTPS, right, or www. So we need to get the certificate first. So we'll navigate to Certificate Manager. Certificate Manager, and then click on request a certificate, and then make sure that this is selected, request a public certificate. Click on next, and here we need to enter this name. So I'll copy this, I'll go here and enter the name, and then add another name to the certificate. We'll add this so that it can cover any other subdomains, and we have to keep the DNS validation selected, and that's it. Let's just click on request. So this might take some time, like as in few minutes to get issued, but before that we also have to add these certificates as records in Route 53. So let's just go ahead and click on this, and then we'll click on create records. So now if I go to Route 53, and here now you'll see extra CNAME records. So you see this record got added automatically. Now we just have to wait for the certificate to get issued. So this shows success, but now if I go to HTTPS the product page.shop, if I try to open this, it still shows site cannot be reached. So this is happening because the certificate is issued, but it is not yet attached to anything that can serve the website, right? So we haven't set up the component that sits in front of the EC2 instance that handle the HTTPS traffic, right, and then forward it to our app, and that component is called Application Load Balancer. So we'll go ahead and set up the Application Load Balancer. So let's just go to our EC2, and from the left panel search for Load Balancer. We'll click on Create Load Balancer. Here we'll select the Application Load Balancer. We'll just click on Create. I'll give a name here, and then internet facing is fine, IPv4. This default VPC is also fine, and here my zone is US East 2, so I'm going to select all the available zones and subnets. And here in the security group, we'll go ahead and create a new security group. I'm naming it as my app, and VPC will keep the default one. And in the inbound rules, we have to have HTTP and HTTPS both. So here let's search for HTTP, and this has to be anywhere IPv4, and let's also search for HTTPS, and this also has to be anywhere IPv4. So this is fine, and that's it. Let's just hit on create security group. So this is created. Now let's go back to that screen and refresh this. So this is the one we just created, right? So I'm going to deselect this one and select this one. Now in the listeners and routing, we have to add HTTP and HTTPS. So in HTTP, in the targets, we are going to create a new target group. So I'll click on this. We'll keep the instances selected, and then in the target group name, protocol HTTP is fine, port 80 is fine. This should be IPv4, and this because in the load balancer also I have selected the default VPC, right? So I'm just gonna leave it as it is. Create this. This is my instance because I have multiple, right? And then creating the target group. Then we'll go back here and let's just refresh refresh this, and here this is the target group that we created, right? So I'll just click on this, and then we'll add, this was HTTP, right? We'll add another listener for HTTPS. So I'll just click on this, and here select HTTPS, and in the default action we'll select this. So this is fine. Now let's just go to default SSL and TLS certificate. So from here we actually need to select one. So from ACM, if I search for the certificates, then yeah, this is the certificate that we have, right? So I'm gonna select it. So I think that should be all. Let's just go ahead and create the load balancer. So this, we need to wait till this status gets active. So this took around 30 minutes for me. Now let's just go ahead and do the next step. Now we'll go ahead and modify the EC2 instance security group to allow traffic from the load balancer, and then we'll also update Route 53 DNS records to point our domain to the load balancer. And then at last we would also have to update Django allowed host and React app backend URL to use our new domain name, because right now it is pointing to the public IPv address. So let's just go ahead and get started with the first point. Then we'll go to our instance. This is my instance, and then under security we can see the security group it is associated to, and this is my security group. So let's just go to the security group, and we have to edit the inbound rules. So here we have to navigate these to our load balancer. So I'm going to first remove this. Let me click on, okay, I need to give the new one. So this is the load balancer that I have. So this is not allowing me. So what I'll do, I'll rather delete and then create a new one. So HTTP and then TCP. Let's just add a new one, and here I'll search for the one that I want to associate it to, and this is fine. Let's just hit on save, and then we have to make this change for custom TCP as well. So let me first remove this. I'll add a new one, custom TCP. The range would be 8000, and here I have to navigate from my load balancer. So this one, and then let's just save the rule. So now what this means is that only traffic which is getting navigated from your load balancer is going to reach to your instance and nothing else. Now let's go to Route 53. We'll go to our hosted zone, and here we would have to create few additional records. I'll hit on create record. So here we don't have to give any name here because this is already there, and then it has to be an A record type, and alias should be switched on. And then here in the choose endpoint we have to select this one, alias to application and classic load balancer. Then select the region. Mine is Ohio. That's what is selected for my instance, so I'm gonna search for that, this one, and then select the load balancer, and that's it. The simple routing, this is fine. We'll create the record. Now we also have to create another record for www subdomain. So I'll click on create record, and here in the subdomain I'm gonna enter that. Here we have to switch it on. It has to be A record type, and then route traffic to, and alias to application and classic load balancer. Choose region. This is my region. We'll select the load balancer, simple routing, and then create record. So this is done. So we have modified the EC2 instance security group, and we have also updated Route 53 DNS records to point our domain to the ALB. So now we have to update the Django allowed host and React app backend URL as well. So I'll go to my backend app, and we'll go to settings.py. So this is the allowed host. So let's just update it. So here we are going to keep this, and I'll also append my domain and subdomain name. So I'm going to add this here. So this is going to be the domain name, and I'm going to append the subdomain name as well here. Then we also have to update the course allowed origin. So we'll scroll down over here. So I'm going to add all of this. So HTTP, HTTPS, and then with www with subdomain as well, right? So I think we are good with this now. Now we'll push the code to Git. So this is done. Now we have to also make changes in the front end. So in the front end we have to go to the workflow. So this is the workflow that we have, and here we have that URL, right? That is what we need to update. So here this is the backend URL, right? So we'll go ahead and update this, and that's all. So let's just save this and push this also to Git. So this is deployed, and also let's just check the front end. This is getting deployed. So this has succeeded as well now. So this seems to be working now. All right. So here this is HTTPS. Even if I type in www dot, it will work as well. So this was HTTPS. Let me try. And it's working here as well.